Hi everyone, my name is Fumiko. Can we start? Okay. I work for this company called World Singles. World Singles is a dating and matchmaking company that operates online personal websites for various communities from all over the world. Today, I'm here to talk about our experience with HoneySQL. I will start with what is HoneySQL and why we use it at World Singles, and then I will show you step-by-step HoneySQL examples, and finally, I will share how we use HoneySQL in our application, including graph menu setup and how we handle filters, joins, and highcharts. What is HoneySQL? It was created by Justin Kramer. With HoneySQL, everything is built on top of Clojure maps, representing SQL queries. This select from where a single thread will produce a Clojure map with select from where keywords like this. Then it can be formatted to a query statement in string using the SQL format function. Since it is a Clojure map, the order of select from where in this example doesn't matter. This will be the same as this one on the right. Both will produce the same query. Later, I will use the fact that it is a Clojure map. I will also contradict myself saying that the order does matter in our implementation. Another thing I would like to mention is that you are responsible for correctness of your queries as you are with string version of query statement. All column names and table names must be correct or your database will throw an exception. Also, if your query with the wrong semantics is executable, it will return wrong data. So why HoneySQL? Like any other web applications, we have hundreds of queries to our database. Queries we know exactly how they look like, such as select everything about the particular user. Last time this user was online, people who they sent messages to, and so on. But what about those we don't know how the queries look like at compile time? So this is a project I started working about 2 years ago called Hubble Scope. Hubble Scope is a data visualization tool for admins. It is entirely customizable at runtime. The duration of data can be as long as 15 years. It is a line graph with maximum of 8 lines. You can draw up to 30 graphs per single request. It also has a total of 17 filters per line. For every graph, x-axis is always dates, and y-axis can be either count, or dollar amount, or percent, like this. It can have more than one y-axis for dollar amount, for example. And for each line selection, you can add an average line, which is a straight dashed line in yellow in this image. For some lines that are too hard to read compared to the other line with a shared y-axis, a multiplier can be added to the line, creating a separate y-axis so that it will help you to see the subtle difference in values. Hubble Scope was and still written in Cold Fusion, JavaScript, MySQL as a database, and we use highcharts for graphing. After the first version of Hubble Scope was up and running, however, I saw some issues. There are lots of string concatenations, lots of similar logics, mostly due to filters, and it quickly became an unrealistic human-facing language. And imagine, even in Clojure, matching string mixed with business logics would be very hard to follow and scale, and difficult to focus on semantics of queries. Not to mention occasionally missing white space, which could cause a MySQL exception. Meanwhile, our requirements were growing, and so we needed something that we can eliminate as much duplicate code as possible and easy to add and modify, and allowed us to focus on semantics of the queries instead of concatenating strings, and maybe separate business logics from queries as much as possible. So I started coding in Clojure, replacing server-side Cold Fusion code in fall 2012. Shortly after, we started using HoneySQL. As a result, Clojure code grew tremendously, computing almost everything possibly computed in the back end. So how did I do this? Let's create a function called revenue. First, First, we require HoneySQL.core and HoneySQL.helpers. By the way, I will go over just a few syntax in this talk. Once you see those examples, other syntax should be easy to apply, mostly in the same manner. Suppose you are interested in the date and the dollar amount columns in the transaction table. Notice the column names and table names are both keywords. The names must match with your database schema. Using a single thread, this example will produce select transaction date and amount from the transaction table. To compute total revenue, you can call SQL call function with the sum aggregation, also as a keyword, which will be applied to the amount column. This becomes select transaction date and sum of amount from transaction. Instead of using SQL call function, it can also be written in this format, that is keyword, which starts with the %, aggregation function, dot, column name. For this presentation, I'm going to use SQL call function for consistency. Since our graph needs X and Y values, let's call the date column as X and the amount column as Y, also call the table alias as T. The format for alias column or table name is a vector of 2 keywords. The first item is column or table name, and followed by alias name. The graph will have a start date. Let's add where condition with a vector of 3 items, an operator, a column, and a value. Here we are adding transaction date is greater than equal to a value, January 1st of this year. We also have the end date, so let's add another vector to the where condition and say transaction date is less than tomorrow. This vector will add and to the where condition for you. You could also parameterize the dates using SQL param function and send parameters in the vector argument in the SQL format call in the order of parameter appearances. Or you could use a bindable parameter using a keyword that starts with a question mark. You can also directly use vars without using parameters. In order to aggregate Y value by day, let's call the date aggregate on the transaction date column so that we can group by the X. And order by X so that data in the result set is in the ascending order by date. You can also use the having function. In this example, total revenue with transaction method equals PayPal. You could also use in operator and start a single thread to create a nested query. Doing so will make the query more complex. For our example, we'll remove having function and nested query for simplicity and refactor select function instead. We will create a function called select XY with X and Y argument. X is always date column and aggregated by date function. It is to ensure that each record set has X and Y values to be translated into a graph later. So select is replaced with select XY function. Next, we'd like to refactor start and end date logic. We create a function called whereDates. This is to ensure that the dates are aggregated in the same manner for any line in any graph. So now where condition is replaced with whereDates function. And since for our purpose, it's always grouped by X, order by X, and then formatted to a string version of query, so we refactor them into group order format function, like this. And so we finally have our revenue function ready. The function will produce a string, select the date of transaction date as X, sum of amount as Y, from transaction as T, where date is greater than equal to start date and end date is less than end date, grouped by X, order by X. Let's create a new query. To compute total revenue count, the only thing that you need to change from our last example is Y value. That is count of transaction ID. Considering those differences, we create a map called revenue map. Each key represents type of revenue, and each value contains Y value. Back to our revenue function, we now have a new argument called revenue type, and you can get Y value in the let binding. If you pass total count as a revenue type, then your query will select count of transaction ID. Now let's create another query by adding a new keyword. new keyword has a value that is a map of y and where keywords. Y value is sum of amount, and where value is new column equals to 1. Going back to our revenue function again, the first thing to do is get y and where condition from revenue map given revenue type. Then, now we are going to use con single thread to test if where condition is true. Con single thread takes a set of test expression at the end of form. If the test expression is true, then form will be evaluated. Otherwise, it will test the next expression. It doesn't halt there like cont. Similarly, adding another revenue type is easy. Like you can see, SQL call function can be nested. In this example, total refund revenue type's y value is absolute value of sum of amount. In order to execute a constructed query, we require Clojure.java.jdbc. It is a Clojure wrapper library for JDBC-based access to database. To execute a query, simply call the library's query function with argument, where the first argument is your database, and the second argument is a complete query statement. For us, that's generated by HoneySQL. Our database is MySQL, so HoneySQL lets you create queries with quoting simply by adding quoting and MySQL keywords to SQL format function. Now, I'm going to show you how we set up the user interface dynamically. We have a total of 116 menu criteria at the moment. In MySQL namespace, we have 16 functions which constructs 106 queries whose data source is MySQL. We define menu as a vector of maps. Each map represents a criteria such as total profiles. To create a menu in user interface, we only pass keys UI needs, such as ID, category, line name, tooltip, and so on. If you want to add, remove, or modify a menu criteria, you only need to edit this map. Using the same map, these highlighted keys are only ones needed in backend for computation. They are ID, source, function, function keys, and default y-axis. So how do we compute data? Recap from the previous section is that we created a revenue function and the revenue map, which has revenue type keys. Each revenue type key has a value y and where as optional. Using this information, we can assign function is revenue and function keys is total for ID 1, as in total revenue, for example. So given ID from UI, we can obtain function and a key to construct and run a query at runtime. What we are trying to do is call the function with the function keys. What about filters? Filters has two parts. One, before you construct a query. Two, when you construct a query. What does that mean? We have 12 generic filters can be applied to almost every criteria, such as site, site group, country, gender, age, locale, and so on. We also have 5 category-specific filters. For example, for the revenue category, membership package, payment method, promo code. For the screening category, we have admin ID to identify who screened the photo, for example. Before constructing a query, there are 3 things need to be done. 1, clean up filters. 2, apply business logic. 3, generate string to display filter description in the graph. Why do we want to clean filters? We'd like to leave only filters we need in query. In other words, if we don't need to filter in SQL statement, we want to remove it. For example, country code is a string. In our application, an empty string means all countries. What does this mean in a query? It means we don't want to filter by a country. So we remove this filter from the list. And it's done in a different namespace called filters. Why in a different namespace? Because namespace to construct a query, which is MySQL, knows only table structures. If you pass a country filter with an empty string or nil, it will try to match where country is equal to an empty string. This means that if default value changes, you only need to make a change in the filter's namespace, not in MySQL. Another filter that needs to be removed is a filter that isn't associated with the correct criteria. Say you select admin screening category, and the promo code filter is selected, which is for the revenue category. We don't care about the promo code for this criteria, so we remove it. So cleanup means keep only filters needed in the query. Another thing we do in the filters namespace is to apply business logics related to filters. For example, we have priorities amongst site group to draw multiple graphs, site group to filter for a single line, and site to filter for a single line. Depending on their values, we either remove, modify, or add filters to generate data for a graph we intend to draw. Another example is mutually exclusive filters. Even though it is enforced in UI so that one of them is true, we do this in the backend as well. As you know, if both are true, there will be no data, which we don't want. Depending on business logic, we remove, modify, or add filter and prepare for building a query. Another thing we do in the filter namespace is to generate a string to display filter name if necessary and its value. For example, if we display USA, then you know that is a country filter. But if we display eligiblegreeks.com, then we don't know if it's a site or site group, because it can be also a site group name. Same for age. If we just display age, we wouldn't know if it's a min age or max age. Most filters in data is an ID, so we also need to convert them into something meaningful to user by using lookup. Going back to our revenue function example, now we would like to add the function called add filters, which will work for any function to generate a query. When you filter data by a certain column, you need to make sure that the column exists in one of the tables in your query. If it doesn't, then you have to join the table, which has the column you want to filter with. So I define here something called tables. What it is that each key is a table name, and each table has a table as a vector format so that you can use it in from or join function with HoneySQL. And each table has also columns that I need to draw a graph. So why I do this is that this is the only place I have to look up to draw a graph. So it tells me all tables I need to draw a graph, and all columns I need to draw a graph for each table. And so the joining process is usually it's a manual process that you have to manually look your SQL statement and see if it's not there, then I have to join. And then I thought myself, maybe I can let Clojure do the job for me. So once I define these tables, then I have a bunch of functions that does the joining process for me. So one of them is called table as. So what it does is you give SQL map and table name, not a vector, table as a keyword. And then it will return table alias name. So in the code, I will never have to remember what table alias name was. And similarly, I have this function, it's called SQL to column. So it takes SQL map and then column lookup. What it does is first look for the column in from table. If it's there, then it will return the column that you are looking for from the from table. And if it doesn't, then it will look for join tables and to see if one of the join tables has the column that you're looking for, then it will return it. If not, then it returns nil. You can do this because SQL map is a Clojure map. Imagine if this was a string, it would be very hard to do. And using this function, you can create a bunch of functions like this one, site ID column. So it takes SQL map, and then it returns site ID column to either join on or filter by. And so now, once you know how to get the column you're looking for, then it's time to actually filter. Going back to add filters function, we are going to take a look at the filtering process, how it works. And one of the example is add site group IDs function. So the first thing it does is to see if site IDs, that's a vector, if it's not empty, then in the iflet, I would try to find the site ID column. If it finds it, then I simply merge where condition, such as site ID column is in site IDs as vector. And if it doesn't find the site ID column in SQL map, then you first have to join a table. In this case, it's a user table, and then you merge where condition. So then there's another case that one column could mean more than, I'm sorry, one concept means more than one column in a table. What I mean by that is that, for example, like in a message table, a user can be a recipient user or a sender user. When viewing a profile, a user can be a viewed user or a viewer user for profile view function. And I have a map with type of queries as keys, and each have associated user ID columns. So when you are trying to query unique viewed users, then your user ID column, you want to join on viewed user ID. And since SQL is a Clojure map in HoneySQL and Untitled format, I'm simply associating user ID column to the SQL before calling add_filter function, so that I can join on the correct user ID. Correct user ID column. During filtering process, it will first look to see if there is user ID column exist, and if not, check from table followed by join tables as we did before. So now you can safely call add filters in any function, but I have to say with this implementation, the order does matter to make it work as intended. So the last item I'm going to talk about is how to manipulate highcharts in the back end. Highcharts is an interactive JavaScript chart. Recall there are requirements that Hubble scopes graph can have more than one y-axis depending on user selection and data. In highcharts, a graph is expressed as a JSON format. And I thought to myself, what if I could compute everything I can and pass a graph as JSON format back to the front end? And thanks to Clojure.data.json library, this was easily done. And let's put together things we discussed so far. From the front end, this is the function to return a graph object in JSON format given start date, end date, and line criteria. First, we clean filters, as we talked, and then we use pmap to compute data by generating a query with HoneySQL. Up to this point, the pipeline represents lines in the graph. The last operation in the pipeline is a graph function. This is in highcharts namespace. The graph function can be a def multi if you have more than one tool to graph, and the user can choose which kind of graph they want to draw at runtime. But for our purpose, it's only with highcharts, so I'm simply calling graph function here. So in Clojure, a graph is just a map with y-axis, and that is a list of y-axes, and series, that is a vector of lines as maps. You can also add title to the graph if you would like. But the most important part is that y-axis in each line in series must exist in one y-axis. And the data that you computed using HoneySQL will be applied to data in each line in series. So you were simply passing a graph object or map from the back end to the front end, and in JavaScript, you simply assign graph.y-axis into highcharts y-axis. And similarly, you can assign series to highcharts series. And y-axis has, obviously the most important thing is ID, and Other attributes are like minimum value, maximum value, and for our purpose, we need a multiplier and so on to compute y-axis. And to compute all y-axes, we have to iterate each data in series. So we start with empty vectors for y-axis in series. That's our initial state. And the first thing, you just push the line, and then y-axis associated with that line. But the second time, you either use the existing y-axis, or you have to add the new y-axis depending on the data. So along the way, I ask this question, does this use default y-axis, or does this need a new y-axis, or does this need to work with a multiplier? I work through, and then few of the functions that I can show is like a new y-axis question mark function, which returns a true or false to say if the data requires new y-axis or not. And another function is y-axis max ID, which will return ID of y-axis that has max value amongst all y-axes. And y-axis next ID would return next ID to assign given the current y-axis. Another thing I would like to mention is highcharts uses JS epoch time. What is JS epoch time? It is a JavaScript date time stamp in milliseconds since January 1st, 1970. In Clojure, it is java.lang.long data type. And it can be done easily by using cljtime.cores, cljtime.core. Aside from y-axis computation, another thing we do is add long dash line. For average line, you can ASOC dash style key and styling string into a line. Did I just say ASOC? I'm sorry, associate. Another thing I did not too long ago was adding xplot line to the graph. I computed all Sundays from start to end date and mapped the with date for Sundays and color. It's easy to create and manipulate a Clojure data structure converted into JSON string. And the very last thing, extensibility. HoneySQL can be extended, and I've done two things 2 years ago, both of which are no longer necessary. One is using extend protocol to SQL at the backtick to table and column names. As I said before, this can be done by just adding quoting and MySQL keywords when you format. Another thing was adding a function handler. This is for in operator. I believe this is straightforward. The very last thing I would like to mention is Hubble Scope's other features. Creating UI dynamically, constructing a query, and drawing a graph were made possible by Clojure, HoneySQL, and highcharts, all of which are data-driven. It worked seamlessly. We were able to add another feature and let a user save a graph. We store a graph as a data structure in MongoDB in a JSON format. It was easy for us to retrieve a graph through Clojure, HoneySQL, and highcharts again. We were also able to add an alert system, which allows user to set a threshold to a line and send them a notification. Since alert cron job is run every 4 hours and not every 24 hours, we tweaked the select XY function, and we saw earlier that was easy to do. In conclusion, I would like to say that Hubble Scope became one of our success stories using Clojure and HoneySQL at World Singles. And a special thank you to, this was my very first public speaking. Thank you so much for